for your introduction. As you said, my name is Denis Roussel, so I'm a data scientist. And today I want to talk about my job, what I do. How can we turn data sets into meaningful value, even though we're not talking about hype subjects like deep learning, data, but we can still have some understanding. Okay, so first question is, what does a data scientist do? In my opinion, main focus on the data scientist answering what's true. This question can come from different scenarios. When I first started, I thought that a data scientist will deal with companies who come to him and have a bunch of data. Can you? Unfortunately, it never happens. Why? Because data scientist is expensive. It's also expensive to export a bunch of data. You don't know what it never get data. So what's more likely to happen is the company has something in mind, like I want to do predictions, applications. I have some data, I don't have the knowledge. Ask, okay, can you do that for me? And with the data you get, you works things down. The scenario is browse the internet and happen to find some interesting data. So for example, let's say you're a routing company and you help people drive through maps and you find traffic data. So that really can help your business. You can use those data to build a better product. That's another thing. And the last scenario I can think of is just curious about something. You have subjects interest you, just go for them. So that's, I'm going to show what's this scenario with my example. So back in 2018, I was paying my taxes. In France, we have a website where you pay your taxes. And in the website, I noticed just one menu called statistics. I was just curious, so I clicked on it. And under this menu, there was some menu called, I'm very excited. You can choose the year in 2011, 2017. And what you get, a nice spreadsheet with hundreds of sheets, nice tables, although they're not very well structured. But in my opinion, it was pretty good. And at the same time, I was watching a YouTube video about how people can measure inequalities in countries. Like, how can you say that 1% of the population have as much wealth as? So I had both. I have the data and I had objective, I have my questions. So can we show inequality? Just based on data, calculated data we get from our websites. So I was ready on an adventure. So this is me with my spreadsheets and I'm just running to my computer. So first thing to do when you have data is to import it. Excel files, so it's not a big deal, but a bunch of them. Fortunately, R is very good at doing things very quick. So I could just say, okay, I have my functions. My word functions would take just a file name as an input. File name is in URL. I just file it, read it with red Excel, put that into a nice per map functions to get a nice data frame, and this should work perfectly. Unfortunately, when we work with data and also data that change over time, the structure might not stay the same always. And some things can change over time that work. Here's a list of things that change with those data. So once again, data were from 2011 to 2010. First thing that changed is file name is not consistent with here, just an underscore. Yes, that makes sense, but that breaks the flow in it. Another thing that changed is first files were in XLS format and they changed it to XLSX. For some reason, the XLS format failed to import with Excel. You take care that to transform the X. Other thing, change. In the data sets, there are missing data, as always. First year, they were called n.c, but then they changed it to n.d. This is not very a big deal, but actually brings you some information. n.c means not communicated data, so you don't really know why they did it. n.d is for not disclosed. Not disclosed means they willingly don't share the data with you. That probably means, I don't know, it probably means that for those missing data, there were data inside that wasn't there. And probably it was because there are too little people in this world. Tax data, very personal data, share. Aggregated data. One other thing is, for the first years, only departments. So I don't know, quick survey, how many are French here? Okay, not French, so it's not one French. I don't know if you know where the administrative system in France, so we have regions, department. But at the beginning, there were only departments data, but then they added national and regional data. It's different structure tables, so you need to take. Then, last thing, and you can only know it if you look at the data itself, is that first year taxes and revenues are given in euros, but then thousands of euros. So if you want to compare years together, you need to be aware that later like thousands. Once again, those are not knowledge, but take care of that when you import data. So you build your script. It's a linear script that read Excel, the data. Next question is, where do you store the data? So you build the database. However, database something maybe not a great idea. What we like to do is make data packages. Data packages are just simple R packages, only contains data inside. The great thing about that, lack of versions. In your process, you change the structure of data, you can version of your. So who computed it? Basically, it doesn't add much more work, but it gives you value. For this talk, I also built another data package. Datapole has some so for non-French speakers, France, obviously, France is highly doesn't reach departments. And each department towns or municipalities. Around 35,000 France. That's the granularity of the data we. Okay, so we imported the data. Now the next thing we need to do, any question, is how that it's a data quality. So let's look at that. This is a subset. So now that we have imported into here, it's an example of the thing. Just one minute where I come from. For year 2011, and what we have a bunch of columns. First column is the name of the municipality. Code. The nice thing about that, and that's why I picked the reference category of people where you say, okay, that people who earn less here, number. So data can be used to disparities of count. So yes, one thing also, some universities doesn't have all of those categories. Some totals last line because they are small. So one thing we need to check is how many towns does have multiple categories. And actually, only 15% of towns have just the total. You can notice that the number of towns evolves per year together. That's what just some years some towns are added, some towns. Okay, so to summarize data quality, check have homogeneous geographic information. Everything is homogeneous. See that we have a rows called total, and we have categories. Make sure that the totals correspond to the sum of that. That varieties correspond to departments. Also, data about departments. And finally, values. As I said, there are missing values. 10% missing values in these data sets. Actually, some of the values can be retrieved. We have the total, only one value that appears that total, right total. Sum of about missing values. Very useful. Janitor, Anya. Janitor is more to clean your data frame, the form of the Anya is more values. So now, how can we show inequalities on the data? That's what we want. What we can use is called Lorentz curve. Quick story again, knows Lorentz curve. Okay, not that many. Okay, the Lorentz curve shows a graph, which is the axis, the percent of populations. 100% is all France, 50% half of France. On the y of total weight. So the line, straight line here, perfect equality. So that would be the line. All people would earn the same money. 50%. What we see, for example, compute the data. What we say is that 92% means that other 28 also owns the other. So there are some inequalities. Put a number on this graphic. You can use what we call inequality. Equal to area perfect, the line of perfect equality over the area. There is a mathematical formula. This is just the formula. Here, only formula. Here the functions, again, it's complicated. So now let's try to compute the Gini coefficient for all years, compare that to big data we have. So I get sources, which is World Bank and INSEE. So there are two company organizations. Gather some kind of data. Purple is the tax that the from the tax data. What we can say is, okay, we are a little bit over. However, we are under 5% margin. So for me, it's a win. I like the result. So now we have the Gini coefficient. We know it's working because we have data, we have numbers that are close to what. And now, how can we show this thing? So to do that, I really like building. Gives you some interactivity. For example, in this case, what we see is just the map with the Gini coefficient. The lower gravity, the lower. What we say in France is that there is a difference between middle of France and border like south and south of France is south of France also have a lot of inequality, and big cities also. That's also look Paris. There are differences. There are differences inside down. You can look it. Okay. Just to conclude, what does data science? Those are questions and ask some more because we went some work question because importing data is not always straightforward, especially imported data. Data quality control, for me, is a necessity. It takes a lot of time. It actually helps you understand better what. Data scientists also need to communicate with technical and not an economist, but I need to be able to understand what is, how to implement it. One thing that is making packages adds a lot. Data overall. Thank you.